Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Enrico Belmonte.
Hey, Enrico. Hey, we got a question the other day. This one came in on my About page. So it's one of the ways we advertise getting in touch with us. And it was a good size framing it out. And I did trade email with Jason on back and forth one cycle on this to get a little more definition. But the basic question was, there's a handful of people in the organization that really want to just test one sample and that's good enough. And what he's running into is there are times when that one sample is trying to find, is this like a 10% defect rate? Or is this it's not just does it work or doesn't work, it's trying to find, is it good enough? And I'm not sure if I'm framing it quite correctly, but it was they always ask for a single sample in order to give themselves some sense of confidence. And it was kind of this, we have to do something, so let's just test one. And the gist, I prompted him, so why do you need more samples? And he says, because we have manufacturing variability, we have supplier variability, we have, tolerances that aren't always the same. We might have a drawing tolerance, but the actual tolerance varies.
Yeah.
So I think he gets that there's variation. And if you're looking for a relatively, like, say, just even 10% of the defects, and you only have a sample of one, you have a pretty good chance of getting a sample that's just going to work when you suspect that there's a 10% problem. So have you run into this before? Have you run into folks that just ignored variability?
Yeah, you mean the one sample statistics, right?
Mm-hmm.
That's quite a paradox, first of all. But it's not a trivial. That is not a trivial question, isn't it? Because especially nowadays, companies are facing a lot of want to do to reduce cost, and testing is, of course, causing a lot of cost. So. The question for a reliability engineer: how can you justify the amount of samples you are requiring? Because the more the sample, the more the effort, the higher the effort will be. You need to use more, for example, thermal benches, or more benches in general, more thermal chambers. You need to involve multiple people. It's quite a high cost. So. So first of all, it's not a trivial question, and but of course, as I said before, is a quite a paradox, no?
Mm-hmm.
Even if there are different industry sectors where you must test just one sample, like really expensive tailored machines or rockets or whatever. So it's not like a mass production. So I think we should start. We cannot justify statistically. So there's no way except saying, okay, your margin should be so high that you include the variability in one test. But even in this case, to be quantitative is quite a challenge, no? Because that's pretty much impossible. I would phrase the question differently, So as we say multiple times, as we discuss multiple times, starting from what do you expect from the test,
Right.
Because what I see generally in the company, so people ask, how many samples do I need to test? Because they want to be sure that they get some confidence, But not so many people reflect on what they could expect as outcome of this test.
Yeah,
which
what's
is
the chance
much
of
more,
success? Yeah. It,
yeah, which much more powerful.
yeah, if you can design a test that you're pretty sure that it's going to pass and you won't learn anything. Everything will just work for some duration over some set of stresses and everything else.
Yeah,
And if the chance of finding the level of defects that you're looking for or where it will fail when you expect it to fail, if you don't have enough samples, you won't find it. It will be very unlikely that you'll see a failure.
yeah,
And so then, okay, what did we really learn? And you back out the math and you go, well, there's a 40% chance or like an 80% chance that there's still a 20% defect rate in there, but we didn't have enough samples to detect it. And people kind of roll their eyes at me and go, what? I'm like, okay,
yeah.
you know,
Yeah, but yeah, it's a typical scenario. For example, you said, for example, one sample statistic. Yeah, that's one important point. But I would add also another typical question: how many samples do I need to test in order to achieve a reliability of 90% with a confidence level 90%? The answer is 22, of course, based on binomial distribution. Yeah, but
right?
even in this case, this is not. Uh, Even if it seems to be statistically sound, it doesn't contain any information which is useful for you for on one side to develop a reliable product, the other side to demonstrate the reliability of this product. So
Right.
in general, I would say testing one or multiple sample should be encompassed by reflection about what is going to fail and what are the potential damage mechanism and failure mode. And in this way, you can basically also test just one sample, but you can ask yourself what is going to fail. Yeah, and it's quite different. So because this is driving your choices afterwards. For example, you can
Okay.
take in terms of tolerances an upper limit tolerance part. You can choose, you can process, for example, like injection molded plastic parts, forcing the presence of voids. You can so include some artifacts in order to be, let's say, conservative in your assumption.
Hmm.
But you need to ask yourself what is going to happen. So I think what I really, for me, risky is a blind testing. Just say I tested something, I test one sample, I test 22 samples, but I don't want to see anything except pass or fail. That is
Right.
really, really risky.
Well, it's risky and it's also it's not getting much value out of the investment of doing it. And I had one engineer, they had a copper plates, pretty thick copper plates carrying a pretty good size current. And it was kind of it was, connecting electric vehicle batteries to a system. And so there's these big bus bars and they weren't coated at all. And the application where those copper things were was exposed to the environment. And their first customer was here in California in an area that's famous for what we call tule fog, which is a very thick, you can't see 20 feet in it. It's so
Really.
thick fog, and it's not raining, but you get
Hmm.
wet when you walk through it.
In California, I,
Yeah,
I I didn't know about it. Yeah.
yeah. It's in Central Valley. It's called Tule fog, and I'm not sure why or where the name came from, but it's super hazardous for driving, of course. Yet I was thinking that's like as close to 100% humidity you can possibly get.
Yeah.
And we have this device that's cold overnight, and then this
Yeah.
fog hits it, and there's going to be condensation.
Yeah.
And I said, when it's running and it's warm, you can defend some of that, keep it dry. But what happens when you have condensed liquid on these bus bars, across the two polarities of it? And
Yeah.
so the engineer says, well, we'll just throw it in the chamber and see what happens. And they had a thermal chamber. So he put it in a thermal chamber and said, well, nothing happened. He says, there's no moisture in there.
Yeah.
It's like, well, but nothing happened, so it must be good. And there's no moisture in there. For this kind of corrosion to occur, you need moisture. And so they just put it on the bench, got an eyedropper, dropped a couple pieces on it, and it immediately shorted. Now, we weren't running the full power through it, so it wasn't dangerous, but it was very obvious that this was going to create a short. And the next day, the first prototype up in where this Thule fog is rampant called and says, "Hey, it's not working anymore." And it turned out to be this short, fired off a bunch of fuses and didn't cause a problem. But it's like, come on now. You need to
Yeah.
look for what's the failure mechanism you're looking for. And sometimes, I mean, even one sample can, if you stress it, like in a halt situation, you apply different stresses in different ways until you get failures. You can discover failures. But if you're really just trying to look for confidence that your design works, is what Jason was talking about, well, in what way? And I hadn't thought of it, but you're exactly right, is, well, if we are concerned about variability or like voids or defects or cracks or delaminations or size changes or stuff like that, it may take a little effort to create a sample that's on the edge of what's
Yeah.
tolerable and then test it to see if you got it right or not. And that's a clever way to go about it. Um, Now, there also are circumstances where one sample is just enough. I got a prototype. I want to see if the circuitry has the right timing to tell if the green light will come on when it's supposed to come on. Yeah, one sample is good enough for that. If you've got
For
questions like,
functional analysis, you mean, in this
yeah,
case, not the
just
reliability. Yeah.
and it's
Yeah.
just, do I have the basic structure and architecture right? If I put this gear set together, can a human turn it? What kind of pressure does it take for this to work? Is the motor sized correctly? So it backs up, and you mentioned it, is, well, what are you trying to learn? It's not throw it in the chamber and see what happens. It's, what are you expecting? And asking, what's the failure mechanism? So like that gearbox, if it takes way too much force to get it moving and it stalls the motor, well, we can measure that. Let's just not go pass fail. Let's measure how much effort it takes to move this gearbox. And then
Yeah.
we can engineer out and model what size engine and maybe changes to the gearbox so that we can make it work. Those kinds of questions, a quick sample on the bench, let's try it, let's modify it, try it again, then it's back to the design. You couple that with really good modeling. So I had one case where it was it wasn't restricted to one sample, and it ended up being lots of samples. But the question was, is if we drop this, will this glue joint fail? It was
Hmm.
a handheld device, and they had a glued component on it. And we found out, dropping one of them, and it came right apart, that yes, that was an easy test.
Yeah.
Just it
Yeah.
comes apart. And then the engineer looked at it and he said, but the glue line didn't go all the way through the whole surface. It was only covering 50% of the mating surface. So there's not enough glue there. So we cleaned that one up, put all the glue on it, dropped it, and it dropped 100 times before it failed. And he's like, okay, see, the design is good. It's the manufacturing part. And I said, see,
Yeah.
there's variability and it
Yeah,
matters.
that's definitely a good example. Yeah, and therefore, I think the good habit is um, to do a design review before doing testing. You know,
Hmm.
so testing is not is not a silos activity. That's, I think, is a really risky. When the design and the testing team are not integrated, but the job of designer, it ends with the drawing, and the job of the testing guy starts with getting the sample and ends with pass fail
Hmm.
criterion. Yeah, So and what you just said. So how what is the role of manufacturing? What is the role of process, or what is the role, or what is the impact of the dimensional tolerances? What is the impact of environment condition on, for example, on tolerances? For example, the effect of swelling or
Hmm.
thermal expansion. All these kind of things can be or should be discussed in a dedicated review. And then you say, as you definitely perfectly said, you said basically we should first of all describe what we expect from the test, trying to force the failure, especially in the development phase, and that is quite a scientific approach to do testing.
Hmm.
So in this discussion, we I think we agree we agree in it's not like how many samples, or it's not like can I get some statistics out of one sample. No, is a not well posed question. No, that's I think is the key issue. Yeah,
Yeah, yeah. It's, the scientific process, right? What's your hypothesis? What should
yeah,
or shouldn't it do? Be very clear. Can you measure it? Are we stressing it appropriate? And then design your test and then figure out what
yeah,
you're doing. And yes, sometimes one sample's plenty. If the question you're dealing is, you know, appropriate for one sample to give you that information. Yet when variability comes in, and that's, I learned early on that statistics is the language of variation. It's the way for
yeah,
us to deal with variation. Yeah, we can be clever if we have good models, we have finite element stuff, we have, ability to create custom samples that are on the edges of our very expected variability. Things like that, we can cheat a little bit, right? Yet
yeah,
there's the other piece of his question is people want to build some sense of confidence. And it's one of these things in statistics that we use terms for people that are trained in statistics and have spent time learning what is statistics and all the various terms we deal with. And confidence has a very specific definition in statistics. It's a sense, it's like, will this sample likely represent the whole population? We're
yeah,
going to take a random sample and there's going to be error because we're not measuring everything. And it's related to the confidence of the sample given us a true answer. And it's an unknown quantity that we don't know. So it's kind of a deal to say, are we on track or not? Is this a useful enough sample
yeah,
size? Which has nothing to do with human confidence, that knowing that, like, we set up a time to record today and I had very high confidence that you would show up on time. That's a different confidence. And I think many people we work with that don't have a deep statistical background confuse the two. And testing one sample to see if the green light comes on when I push this button, is that more, I trust that it'll work. I believe it'll work. And if I push the button and it works, then
yeah,
it reinforces that I was right. I have confidence that my design is solid. And
yeah.
which is different than, will it work with all the variations that are going to occur to it as it gets assembled?
Yeah, I think also in this case, phrasing the question the right way could help. Instead of asking for confidence level,
Hmm.
which is I agree with you, is quite abstract. So the question is how confident are you that what you are testing is representing or is going to be reproduced in the whole population.
Hmm.
And
Hmm.
if you say, hey, we are testing 20 samples and the population is like 20 million items, the yeah, just you make a big jump, right, from 20 sample to 20 million. And just to say, hey, if the first time that I got this question, I was pretty surprised. I says, yeah, 20 million could be some variability. Let's focus a little bit more. Let's review a little bit more the process, the tolerances, the material tolerances, and so on. Because 20, you can try to As you apply the binomial distribution, say 22, I got 90% reliability, 90% confidence. But when you say, hey, I have 20 millions,
Yeah,
that's
that means
quite
I,
different.
yeah.
Yeah, quite different story. Yeah.
And it's one of those where, I mean, I look at it more as what's the defect rate you're trying to detect. Because there's there are times I was working with high volume products and they would say we cannot afford more than a 1% defect rate in the field.
Mm,
The warranty will destroy the profit margin.
yeah.
And I said, yeah, okay, then why are we only evaluating to detect a 10% problem? If it's so disastrous at 1%, and they hemmed and hawed and like, well, we can't afford all the samples. Well, can you afford not to know?
Yeah.
It's and the program manager was like, if this goes well, I get promoted, I'll be doing a different job. And so
Yeah.
yeah.
That's classical one. Yeah.
So there's sometimes we just kind of get in a bind for all kinds of different trade-offs and reasons. Yet I think in summary, there are cases where a single sample works, but it takes first understand what do you expect? What are you trying to detect? Where is the pain point or the uncertainty or the question that you have that testing is a way to answer that question, to provide the information. Then go about setting about what you need to do. And if it is involving variability, uh, yeah, sometimes you only get one sample, but you got to rely on modeling and all kinds of other work to understand that your test is confirming a theory versus discovering it.
I want to add a last reflection,
Okay.
Fred. When you said, assuming the scenario, we need 22 samples for having a reliability, for demonstrating reliability of 90% with 90% confidence level, no?
Right.
So you do that uh, as you haven't done anything before. So basically, if you are asked to test a system, say a product, and you
Mm-hmm.
have 22 samples, assuming you have 22 samples, the statistics is not considering all the other analysis you have done on component level, material level,
Mm-hmm.
that
Mm-hmm.
also increase the confidence that you have, because you have been developing not just the product, but also the components inside the product.
Well, that's all that prior works helps you know what kind of
Yeah,
stresses to apply, right? Where
yeah.
you need to apply, where you need to push the products in order for that test to be meaningful. I use that prior knowledge that way
Yeah,
to know where to go.
and that is helpful. And that is by using statistics. Of course, you can include it if you want to quantify somehow. Yeah, but I think in general, it's really important to incorporate all the prior knowledge engineers have on material, on components, on interfaces, and so on, and not just saying I have tested 22 samples and I got the results. Yeah,
Yeah, yeah.
so that's I think
Yeah, that's
important
very true.
reflection.
And it goes back to the you gotta work, you can't throw it over the fence and say, here, go test it, here's the sample.
Yeah.
It's you need to work closely with design to understand what were we trying to do. And I think that was my gist of my answer back to Jason. And but you brought up a couple new points to it. That's why I wanted to talk to you about it. So I'll let him know that when this is scheduled so he can get a fuller answer on that.
Thank you.
But it's one of those that and I actually have a stack of questions here. So I'm looking forward to the next couple of recording sessions because there'll be plenty of stuff to talk about. But we are getting questions. The turn of the year, people are starting to send us questions and comments and things to talk about. So I really, really like that. And so as I always do is, if you've got a question, if you got something that's on your mind or how do I get past this roadblock or how do I better understand it or whatever it is, let us know. Head over to accendoreliability.com/go/SOR. There's a couple of ways to get in touch with us. There's even a way for you to record a message to us, the audio message, that puts it in a format that we can use to include right in the show. So if you really want to join the conversation, hit that button. You can also use our Enrico and I and the other hosts have about pages on Ascendo, and we're also available on LinkedIn. So plenty of ways for you to get in touch with us to ask a question. We'll try to get an answer to you as quick as possible. And And we'll probably then say, well, we can get a better answer if we talk about it. So
Yeah.
like we did today. So thanks so much, Enrico, for helping me flesh this one out and give me another idea that I'll get back to Jason with. And for the listeners, if you got a question, hey, make a note of it and send it over. We'd love to talk about it.
Thank you, Fred. I appreciate our conversation. Thank you very much.
Yeah. Thanks, Enrico. We'll talk to you later. Have a great rest of your day.
Bye.
Bye. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.